invariant isn't just, and this will be important for our differences or agreements or discussion, is the invariant isn't just sitting out there. It's something that is revealed through action. But it's revealed, but what's revealed is a property of the object. So give me, well, I'll come back to that, I promise.
But just one thing, but it's not like the baby's not moving, the baby's eyes are moving. So it's not that there's no movement that is baby's eyes.
Yeah, but with respect to...
Yeah, but if they're not...
But the eyes don't really change the visual angle very much.
Well, but it's a little bit like the detecting, so you need to vary, to detect the invariance of the object, you vary, you saccade.
It isn't the saccades that make a difference, because the saccades, you're not changing your viewing position when you have saccadic movement. I'm talking about literally moving to another viewing position, even a little. And I'll show you some evidence for that later on. But again, if you have any doubts about this, I demonstrate this with my introductory psychology class. I mean, just pick a friend and find some common objects and then tell them to close their eyes and put the object in their hand and tell them not to move their hand and ask them to identify the object. They're going to have a hard time. Ask them to move it around and it is easy. What's the difference between those two cases? By moving the object in your hand, what you're doing is you're detecting invariant properties of the object through action.
Yeah, but I would say that's very different from the baby, because also if you move an object across somebody else's hand,
yeah,
it's also difficult for the person to identify.
Yeah.
Whereas here you're moving the baby around in space. I also wanted to ask what age are they?
Yeah, my memory's crummy, but we're talking about on the order of 3 to 4 weeks. Mm-hmm. You're right, but not completely. It turns out that self-produced action does reveal more information, and I'll try to show you why. But you don't necessarily have to have self-produced action. You can also have passive movement.
I would say in the baby case, that's not actually active perception, but it's multisensory in terms of vestibular, visual invariance or something like
well, vestibular information gives you no information about that, and there's no efference going on because the baby's not doing anything except engaging in saccades.
But then I wouldn't say it's sensory motor.
I'd ever use the word sensory motor. Yeah, and in fact, I'm never going to use the phrase sensory motor. In fact, I think the notion of sensory is dead wrong. Okay, but I'll come back to that. Okay, so if we now, instead of conveying a baby around in an arc, we have a person who can move around. What the person is able to do is sort of adopt different vantage points in the ambient optic array and actually create transformations in the ambient optic array. And here is, since I don't have the talents of doing any animation, this is a poor man's animation. Why is this just going on and on? Oh, sorry, this is my left-right problem here. Okay. So as we move, it's essentially what that moving perceiver is doing is essentially what you do when you move an object in your hand. But in this case, the body is moving in the world and creating, and this is key, transformations in the optic array which enable invariance to be separated or detected in the array. In other words, it's not that you're perceiving something that's static. You need to introduce change in order to reveal what's constant. Transformations, like invariants, are revealed through transformations. And for that reason, invariants are not frozen in time. They're only revealed over time, and I can't emphasize that enough.